In this presentation, we are going to discuss number 13, which is a question that's going to make use of the probability tree diagram to analyze events that happen in succession, one after the other. So in this example, it says Shanna selected one fruit at random from a box containing 30 berries, which is represented by the letter B, and 21 cherries, which is represented by the letter C. So this example is about selecting from a sample. Now she ate it, then randomly select another. So that's two selections, one after the other. And this is an example of selection without replacement, because the first selection, whatever it is, berries or cherries, bear in mind, or you're going to come across that word again. Or is an important word in probability, which has its symbol, the union symbol, and the operation is plus. So as I was saying, in her first selection, she can either select a berry or a cherry, and she's going to eat it, whatever she selects, be it a berry or cherry, and then she's going to select again. So that's two selections. Now, part A says to complete a well-labeled tree diagram to analyze all the possible outcomes with their corresponding probabilities. So it's a scenario of selection without replacement. So here's the probability tree diagram, which is labeled already, and it is completed. So let us break it down. Let us analyze it. As you can see, the sections, the first section is for first selection, and the second section is second selection. And then you've got the third section, which represent the outcome, and the outcomes are making use of these formula for calculation of intersection, which is the conditional formula rearranged. As you can see here, you just multiply across along the branches. So let's analyze the first section in a first selection. So bear in mind, the basket contains 30 berries and 21 cherries. Here it is, 30 berries and 21 cherries when she comes to select for the first time. So when she dips her hand randomly, she can either select a berry or a cherry. Okay, so this section depicts a visual representation of that event of selecting for the first time in the basket. Now, the probability of her getting a berry is equal to 30 over 51, because in her first selection, there are 30 berries out of a total of 51 fruits. Or she can select a cherry. Now, the probability of a cherry would be 21 over 51, because in a first selection, there are 21 cherries out of a total of 51. So again, in a first selection, she can either select a berry or a cherry, probability 30 over 51, 21 over 51 respectively. Now, bear in mind, be it a berry or a cherry, whatever it is, she's going to eat it. So when she comes to select again, there will not be 51 fruits anymore, because one of them would have been eaten, either berry or cherry. So in a second selection, there will be 50 fruits. That is why now you have 50 as the denominator for each possibility. So let's analyze the first possibility. So here it says, if is a berry she selected in the first selection, or after having selected a berry, the probability of her selecting a cherry is 21 over 50, because if it was a berry, Bear in mind, I'm stressing on the word if. If is an important word in probability analysis. It has its own symbol, which is that vertical line. So when you see this vertical line, you've got to say if. So if it's a berry that was selected, there would have still been 21 cherries remaining because it would have been a berry that would have been eaten. Remember the words I'm speaking, conditional would have been if it was a berry. And there would still be 21 cherries. So cherry if berry is 21 over 50, the probability thereof. Or she could have selected another berry, a berry given she have selected a berry before. Now, if it was a berry, then that berry would have been eaten and there would be 29 berries left out of the 50. So the probability of a berry, if berry, is 29 over 50. Or she could have selected a cherry in the first selection. So therefore, the probability of a berry, if cherry, as you can see, this branch is the condition for cherry. As you can see, if cherry, a berry, if cherry, probability thereof is 30 over 50, because if it was a cherry, that cherry would have been eaten and there would still be 30 berries left if it was a cherry. Okay, bear in mind we're analyzing possibilities. That's what the tree is all about, displaying all what is possible. Okay, so I repeat, if it was a cherry, there would have been still 30 berries left. So the probability of a berry, if cherry, is 30 over 50. Or she could select a cherry, given that she has selected a cherry before. So if it was a cherry, that cherry would have been eaten and there would be one less cherry. So when she comes again, second selection, cherry, if cherry, the probability thereof is 20 over 50. So as you can see, the conditions are represented. Now the outcome, you have to use the word and. So after the two selection, she could have selected a berry in the first selection and a cherry in the second selection. That is possible. There's a probability of that happening, and you can see the use of the word and here because we are talking about the outcomes. It is possible after both selections, she could have selected a berry and then a cherry. And to calculate that probability, we have to apply this formula, 30 over 51, here it is, multiplied to 21 over 50, which is 630 over 2550. You can leave it like this. You don't have to simplify. You don't have to convert it to a decimal. But if you want, you can. Or she can select a berry and then another berry. That is possible. Berry in the first and berry in the second. So that would be 30 over 51 times 29 over 50. Here it is 30 over 51 times 29 over 50, and that is 870 over 2550. Or, because all these are odds, or a cherry in the first selection and a berry, and then a berry in the second. And that will be 21 over 51 times 30 over 50, which is 630 over 2550. Or two cherries, cherry and cherry. Cherry followed by a cherry, which is 21 over 51 times 20 over 50, probability thereof, which is 420 over 2550. Now we are going to use these values, the outcome values, to answer the follow-up questions. Here you have the follow-up questions. We will start first with, what's the probability of her selecting two cherries, a cherry and a cherry? Okay, this is the symbol for and, the intersection symbol. So cherry and cherry, cherry in the first and cherry in the second. Here it is, 420 over 2550. What is the probability of us selecting a berry followed by a cherry? Berry, then cherry. As you can see, berry, then cherry, 640 over 2550, 2550. And at least one cherry, meaning it could be one or two, So you simply add all where cherries are present, because she can select a cherry this way, which is berry, then cherry, or cherry, then berry, or cherry, then cherry. At least one includes the two, because at least it's more than or equal to one. So we add all of this because or implies the operation addition, and we get 2,140 over 2,550. And last but not least was the probability of selecting a cherry, meaning one cherry. So she can select a cherry in the first selection, or she can select a cherry in the second selection. So there are two ways she can select a cherry. And as you are hearing the word or, we have to add, and that will be 1,260 over 2,550. So you need to take out your pen, your calculator, your paper, and actually perform this question. Do it several times, not just once, as a preparation to learn how to use the tree diagram to do probability analysis, and also to prepare for your evaluation.